Now, one case we haven't talked about is when we get a repeated root, which means basically the same solution twice. And when that happens, of course, we can't just add two things with, let's just say 3 to the n, because then that's, if you have a times 3 to the n plus b times 3 to the n, well, that's only really one answer. You can combine those. So that's not going to work. So when the roots repeat, here's our solution. We say that it's c1 times alpha to the n plus c2 times n times alpha to the n. So we put an n in front of the other one. So like I said, when the roots repeat, that's what we're going to do. So here's an example. So again, we assume a form an equals t to the n. So that means we have t to the n is equal to 8 t to the n minus 1 minus 16 t to the n minus 2. And we'll divide through by t to the n minus 2. We kind of already know what happens already. And then we're going to move everything to one side because we're hoping to be able to factor it, or at least use the quadratic formula. And this one we can factor. And this is what's meant by a repeated solution. We get t equals 4, and that's the only one. And since we're trying to solve a quadratic, we're expecting 2 solutions. So that means that this one is repeated. It comes up as a factor twice. So that means that our solution, a sub n is equal to, now I use c1 and c2 in the general idea up here. You can use whatever constant you want to. I am going to call them c1 and c2 just this time. So we know the solution is c1 times 4 to the n plus c2 times n times 4 to the n. So from here, same idea. Substitute and solve to get c1 and c2. So this is our new goal. What are c1 and c2 so this works? So we know that a sub 0 is equal to c1 times, well, anything to the 0 is 1, plus c2 times 0 times anything to the 0 is 1. We really don't care what that is because that whole term is going to just wipe out, and we get 1. So this means after we simplify everything, c1 is equal to 1. Beautiful. Okay, so a sub 1 is equal to c1 times 4 to the first, plus c2 times 1 times 4 to the first. And that means, and that's going to be equal to 2. So this means that 4c1 plus 4c2 is equal to 2. Now, we already know that c1 is 1. So that means that 4 plus 4c2 is equal to 2, which means 4c2 is equal to negative 2, which means c2 is equal to negative 1/2. So now we have the general form for our solution. So a sub n is equal to, c1 is 1, so that means 4 to the n. c2 is a negative 1/2, so I have minus 1/2 times n times 4 to the n. And sometimes what I do when the same term comes up twice, that 4 to the n, I factor it out. So it's 4 to the n times 1 minus 1/2 n. And that is sometimes just easier to look at. So there is our solution to that recurrence. So in other words, if I have something that is following this recurrence, I can use this formula to find any term I want to. So I don't need to know what A9 and A8 are to find A10. I can use my formula right here. Thanks for watching.